Chapter 1, Lesson 2, looking at characteristics of a function when we're analyzing, and we want to look at boundedness and extrema in this video. Boundedness has to do with pretty much what the word says. It's bounded. I mean, there's a boundary at which the graph does not go beyond. And looking at a graph graphically, I was just going to say, but that's kind of the same thing. But looking at a graph, it's pretty easily seen because you can tell if it reaches a height that never goes above that or below. There's three types of boundedness. Bounded above means there's one value in the range that's higher than any other value. Basically, you have a graph that reaches a high point and nowhere else in the graph does it go above this point. So this is the boundary above that the graph never goes above. So this would be called a bounded above graph. You do have bounded below, which means there's one value in the range that's lower than all other values. So if you look at a parabola, this value right here, which happens to be on the x-axis, the graph never goes below this value, so this is the boundary below of this graph. So this graph would be considered bounded below. Whoops. And then you have bounded, which simply means that the graph has a high point and a low point that it never goes above. And a sine graph or cosine graph would be one of these. Notice it never goes above 1, so it's bounded above, and it never goes beyond below this, it's bounded below. So if it's bounded above and below, we just say the word bounded. We don't write bounded above and bounded below, we just say the word bounded. So bounded above means it has an upper boundary that it doesn't go above. Bounded below means it has a lower boundary which it does not go below, and bounded means there's an upper bound and a lower boundary that the graph never crosses. So that is boundedness, and that's the first thing we want to look at. The next thing we want to look at is extrema. It talks about being the extremes of the graphs, and we have local, what we call local and absolutes. And when we're talking about extrema, we're actually talking about the high points or low points of the graph, a maximum or a min. Okay, so it's the point where the function will change from increasing to decreasing. So we looked at those before. The y values are going up, and then at some point they turn around and going back down. That point at which they turn around is called the extrema. If it's going up and then down, it's a maximum because it reaches a maximum point, like a roller coaster, and then goes down. And then a local minimum would be where it reaches its low point and that graph changes from going down to now it turns around and goes back up. So these are called local extrema, or a local max, or a local min. Okay, you may have more than one. In other words, the graph like that bounded one we saw went up and down. You have multiple maxes and multiple mins, and these are called local extrema. Now, the local max or local min may not be the high point or low point of the entire graph. That would be the absolute max or min, because the graph may go up and then down and then go up after this. So it has a local extrema or a local max, but it's not the maximum of the entire function. And I'll take a look at a couple of examples here and I'll show you that. So for instance, if we're looking at this graph right here, let me just change a couple of things here. I want you to notice how this graph, let's just look in this shaded area right here. Okay, and this is why it's called a local, is because we're only going to look at this interval. You'll notice that the graph goes up like this, and then it reaches this point right here, and then turns around and goes back down. This is a local maximum. Okay, and then if we were to move over here and look at this section right here, you notice we have the graph comes down and it turns around right here and turns around back up. So this is called a local minimum. And then if we look over here just a little bit further, we have another maximum right here. It turns around and goes down. It's from increasing to decreasing. But then as we look at it here, you'll notice that this graph goes down forever. So even though this over here is a minimum, it's only a local minimum, not an absolute, because the graph actually goes down forever. So it's not, it doesn't have a minimum value that is lower than every other one, unless we're only looking in this local area right here. This is why it's called a local minimum as opposed to an absolute minimum. Now this graph is bounded above because it never goes above this point, but is not bounded below because it does go down forever. So that's what local extrema are. That's what local extrema means. We're talking about local maximums and local minimums. Now, there is some vocabulary that I want you to be very aware of when you're doing these problems, so you know what's being asked for. Okay? When the question asks what, the word what is the maximum or what is the minimum? What I'm looking for is the y value of the extremum. Now, that point is a maximum or minimum, has an x and a y value associated with it. Every point on the graph does. When I ask you what is the minimum, I'm asking you the y value. That's what is the maximum or minimum. That's going to be y values. When it asks where does that max or minimum occur, where means the x value of that maximum or minimum. So it's very important to know the difference between the two. So if we go back to what we're looking at before, here's a local maximum. If I were to ask you what is the maximum, I'm looking for the y value. The maximum is 9.32. If I asked where is the maximum, I'm looking for the x value at negative 2.5. Okay, so what means the y value? Where means the x value? So here, a local minimum. What is the minimum? Negative 4.86. Where is the minimum? Well, it's at x equals 2.45. Okay, so it's very important that we understand what we're talking about when we're looking at these, when we're talking about what and where. Here for this maximum, what is the maximum? 1.74. Where is this maximum? At 6.5, the x value. Okay, so that's maximum and minimum, local max, local min, and boundedness.